Alright, welcome back. We're finally going back into proving triangles are congruent, but this time we're going to use specific postulates called side, 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 and side angle, side, 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 side. Sounds like it should be a song, right? Side, side, side. But anyways, today you will use the side, side, side postulate and the side angle side postulate to test for triangle congruence. So what shall we do? Let's find out. Okay, so here's the postulates 4.1. Start us all off. Notice this is a postulate, so this is not a theorem. This is something that you kind of have to accept as being true. We showed that if we have all three sides congruent and all three angles congruent, then that we can assume that the two triangles are congruent. So now we're saying that if we at least have the three sides congruent, then we can say that the triangles are congruent. So how do I prove that? Let's talk about one. Okay, so here's a drawing. Like how I drew that out? Okay, and we're going to give you this. That QSR is an isosceles triangle. So we're saying that these two sides are isosceles. And RT bisects QS at point T. Now you're going to prove that QRT is congruent to SRT. Okay, triangle, triangle. Alright, so what do we always start off with? We always start off with the given. So this time I just said, okay, well, based on the given, saying it was an isosceles triangle, QR and SR are congruent. Also, RT bisects QS at T. What does that mean? Okay, I don't know. Well, let's first find out. Okay, so what I did here was this. And step 2 and step 3 could have been either one. Okay, but I chose the little number in the middle, RT. The line segment in the middle. And I decided, okay, let me start off with that, saying that line is congruent to itself, because that's kind of like, duh. It's a reflexive property. Okay? Now, don't know why I'm putting number 2 there again. I'll fix that. QT and ST, if you go back to the drawing, QT and ST are also congruent. Why? By definition of a bisector. That's why. Here's where I'm going to finally erase that, by the way. So, now, if you think about it, I have now shown all three sides of the triangles are congruent. So by the postulate, the triangles are congruent. Since all three sets of sides are congruent by side, 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 postulate 4.1, the triangles are congruent. And there you go. All right. Now here's a little bit harder one. If you have a triangle JKL that has vertices J 2.5, 1, 1, and L, 5, 2. I think this is a 2. There's something in my way. Anyway, triangle NPQ has vertices, Okay, how can I show that triangle JKL, how can I show that the two triangles are congruent? Let me rephrase it. So we're going to cross this out for a second here. And we're just going to say, how can I show the triangles are congruent? Okay. And you'll see why I'm saying that right now, because I didn't know this as I was working the problem, and the book had a weird, I don't even want to explain that. Anyways, now look, we can graph this on graph paper, and you could look at it and you can go, I think it looks good. It looks about the same. And no. I say nay. Can't do that. We want to prove it. So let's come back to the distance formula from before. Okay, so we're going to show that. So how does that work? We're going to use this formula, and we're going to go, okay, I'm going to find the distance from J to K, K to L, L to J. Notice that I went in order J, K, K, L, like I have a triangle J, K, L, but I go J, K, K, L, L, J. So I kind of go all the way around. Then I'm going to also do the same thing for NP, PQ, and QN. Yes, this is a little bit of work, but all of this practically is something you can type into your calculator. So I'm going to write all these out. Actually, I'm just going to do it like that. Boom. Okay, so there's the distance formula, and I put in all the numbers for all of them. Okay, then after that, all I got to do is pop it into the calculator, and then just start pressing enter. So pop it into the calculator, JK, and I get a distance of 4.123. I'll take the decimal answer. I don't need a simplified radical. We'll talk about simplified radicals later, but not right now. NP, same thing, 4.123. That'll work. Okay, actually I'm going to check that off later. Okay, KL, 4.123. PQ, 4.242. Oh, no, they don't match. This means they must not be congruent. Ah, but wait. Check all the work. You might need to. Ugh, I hate that bell. Anyways, LJ, 4.242. Oh, I see something. QN, 4.123. Booyah! Okay, obviously these are isosceles triangles each. And we can see now, like, okay, I can say JK and NP go together. But it's obvious KL and PQ don't go together. It's more that, say, KL and QN go together, and PQ and LJ go together. So I may have to like reorder this, maybe try something like, okay, JKL is congruent to NQP. So that way I go kind of like, that way I kind of establish that, like say which two sides need to be kind of moved around. And maybe that kind of helps me make sure that the points are what they need to be. And then finally, we have another one that says postulate 4.2, side angle side. If you've got a side, and notice that the angle has to be inside, included inside. Okay, can't be one that's like, say, here's a side, and then let me look at this angle. Okay, then if that works for both of those, then the triangles are congruent. I don't have a really good example for that because the book for some reason didn't give me one, which is weird. But we'll talk about that more in class. Anyways, that's it for today, guys. We've got two new postulates to remember, side, 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 and side angle side. So you got to remember. And can you tell which one you need when? Okay, we'll see that in the assignment. Anyways, that's it for today. Thank you so much for your time. Y'all take care.